Welcome student in our virtual classroom. I am going to discuss today a new chapter, friction. To some extent all of you have the idea what is friction. Friction is a resistance to motion. In this regard I want to mention you that all the surface is considered a rough surface, means a roughness is there. Maybe a plane of a mirror, that is also rough, but roughness is very small amount, but roughness is there. And when two rigid body is in contact, then with respect to one another, when it tends to move, slide, then there is a friction along the contact surface, this surface and this surface. And what's the function of this friction? This friction opposes the motion. When you are applying a force here on this block, it tends to move. According to Newton's law, you are applying force, it tends to accelerate. But this friction force resists the motion. Even if it is not moving at all, but friction may there when it tends to move. I repeat, let's consider this is the table, one surface. This is the block. It is placed like this. Is there any friction? Answer is no, there is no friction between the block and the table. Now you are applying a force here using this pen. You are applying force to the block. It tends to move, or it is moving. It is moving, definitely opposite direction there is a friction. But if this force applied force is small, it is not moving, but it tends to move. Tendency is to move. Then also there is a friction. If you are applying no force, only block is there, there is no friction. So this is the friction, and in details with the help of some examples I will explain you what is a friction. Please follow the lecture. To explain the concept of friction, let us consider a block of weight W is placed on an inclined plane. So from our experience we know that it may be in static equilibrium, or it may slide down. For a certain value of theta only, it will slide down, otherwise it will be in static equilibrium. Now let's consider for this particular value of theta, it is resting on the plane. Then what forces are working there? Let's draw the free body diagram of the block. Weight W that is working vertically, and there is a contact surface between the block and this plane, common contact surface. We know that a normal reaction force is working in all contact surfaces. So the normal reaction force is this, which is perpendicular to the contact surface. Now what's the direction? This normal reaction is an internal force between the block and the inclined plane. Means block is giving the force to the plane, and plane is also giving to the force to the block. Then what's the direction? When the block is giving the force to the inclined plane, this direction is opposite to this one. When the plane is giving to the block, then this is the direction. Perpendicular and towards the block. Whereas if the reaction is given by the block, then towards the inclined plane. So this is how we will have to find out the normal reaction. In all contact surface, there is an equal and opposite reaction. If the we are considering the uh, force is given by the block to the plane is action, then opposite to this means by the plane to the block is the reaction. So this is normal reaction force. And another force is the friction, definitely. And we know that friction is always opposes the motion. Now, if it is in static equilibrium, the block is not moving at all, but it tends to slide down to the plane. So, the frictional force is opposite to the motion, tends to move. It tends to move down, so friction is up along the contact plane. So, this is the direction of it. Now, resolve the forces. If this angle is theta, then if this is sin theta and this is equals to cos theta, and similarly in sin theta cos theta, resolve the force in horizontal and vertical direction. And not necessarily that always you have to resolve in horizontal and vertical only. You can choose any two mutual perpendicular direction. Say along the contact plane, another direction is perpendicular to the contact. No issue. So we can resolve this force like this. Now write down the condition of static equilibrium. As initially we have assumed that under the action of these forces, the block is in static equilibrium. So summation of Fx equals to 0. Then sum of all horizontal forces, this is in rightward direction, this is in leftward direction. So minus and nothing else. So that is equals to 0. So from here we are getting tan theta equals to F by N. Again, for summation of in the vertical direction, summation of Fy equals to 0, because it has no movement in x or y direction. So in both the direction, resultant force is 0. In vertical direction, the force component this and this. These two are upward and this is downward. So this is two positive and one is negative. Now solving this equation 1 and 2, we are getting F by N equals to tan theta. Here it is given tan phi. What is phi? Here we need to understand that for this equation, whatever friction is developed, it is for any value of theta. But when for a certain value of theta, block tends to move down, then this particular friction is called limiting friction, and this limiting friction occurs for a certain value of theta only. I repeat, for a particular value of theta only, the block tends to slide down. That particular value of theta is termed as here phi, which is also known as angle of friction. Then from this equation, tan phi equals to F by N. Here in this equation, this friction is called the limiting friction or maximum value of friction force. Here it is not the maximum, it is any value of friction. It depends, this value depends on this angle. But now, this value independence of theta for this equation. So it is called the limiting friction. Now, the ratio between this limiting friction and normal reaction. Point should be noted. Normal reaction is not depends on frictional force. Normal reaction and frictional force is mutually perpendicular. So it is independent. Definitely the normal reaction depends on the value of theta and they applied for W, but not depends on friction. So N and F is independent. Now this limiting friction and the normal reaction ratio is denoted by symbol mu s. This mu s is called coefficient of static friction. Coefficient of static friction. So finally, F equals to limit F equals to mu s n, or limiting friction equals to mu s n. And substituting this value, we also can get the value of normal reaction here. From this equation too, we can get the magnitude of normal reaction. W equals to mg. Now here we are going to discuss Coulomb law of friction. Let's consider this statement is given here. Let's consider a block of weight W is placed on an horizontal plane and a pulling force is applied there, P force. There is a contact surface between the floor and the block. So definitely as the pulling force tends to move the block right, a frictional force Ff is working opposite to that along the contact surface. Now this friction surface, this frictional force may or may not be limiting friction. That depends on P. From our experience, we know that this may be pulling or pushing force, whatever is it. If a block is there and you are by your hand, you tends to pull it or push it. If it is considered a heavy box, so when you are applying a small force, you are unable to move it. Means in that case, the friction developed is equal to your applied force. Slightly increase your force, then also you are unable to move. Means when you are increasing the force, the opposing force, this friction force is also increasing. Means this friction force is proportional to the applied force. Now for this condition, we can write down the condition of static equilibrium as it is still it is not moving. So summation of Fx 0. So from here this equation P minus F means this is Ff actually. So P equals to Ff. And from the vertical equation W equals to N. Fine. Then it is if it is the limiting friction means means when you are increasing the load P, applied force P, friction is increasing. But this proportionality does not holds good for all the value of P. For a certain value of P, certain high value of P, you will reach frictional force. After that, if you increase frictional force maximum, and after that, if you increase the applied force, then also friction will remain same. This friction has a maximum limit. The friction means the resisting. This resisting force has a maximum limit. If your applied force is more than the resisting, this resisting force, frictional force, the block will start to move. This is the limiting friction. And for this limiting friction, we can write down F equals to mu, or mu is the coefficient of static friction that I have derived in the last slide. So this Ff is less than the limiting friction. Then applied force, if the Ff frictional force is less than the limiting friction, then the applied force is proportional or equal to the friction force. Friction force equals to the applied force. Now, for the limiting value, F is equals to mu Sn, and for the means for the limiting friction, this equation does not hold good. Rather, friction has the maximum value, static friction, while when it is under motion, then this friction slightly reduces, and then it is called the kinetic friction. This is also a limiting friction. It's a fixed constant value. While motion, this friction decreases. And the coefficient of the static friction to dynamic friction, there is also a decrement. That can be represented in a graph here, means for the value when the frictional force is less than limiting friction, then P equals to F. Again, for the limiting friction also, P equals to F. But if we increase the P force, then the friction suddenly drops, and whatever may be the applied force, there is a mistake of this diagram. Actually, this is P force and this is the friction force. This is force P and this is force F. Ff. This is the mistake here. Whatever may be the magnitude of this force, P force, friction has a maximum and this constant value. Now we will discuss the cone of friction. What is that? Let's consider again a cylinder is placed on a horizontal floor. The weight of the cylinder W is working vertically downward, and you are applying a force P, and as a result, a friction will uh, resist the motion of the cylinder in the direction of P. Now let's consider this friction is here, the limiting friction. Now, direction of normal reaction is perpendicular to the contact surface, is vertical. Now, if we draw the resultant of this force, friction force F and the normal reaction N, then the resultant is this. Just draw the rectangle using these two vector N and F. Then the diagonal of this rectangle is the resultant. And from this equation, from this diagram, from this triangle, we can say that this is equals to F, this line is equals to F. So tan phi equals to F by N. Means tan phi equals to mu, equals to the coefficient of friction. Now, if your P is applying, means is rotating, means P is applying through this point, through this point, this point, this point, means P is rotating in the horizontal plane. S will also rotate, keeping the magnitude same. S is also rotate. After rotating of this S, the resultant, it will produce a cone. This cone is called cone of friction. Sometimes it is also known as friction cone. Now, another very well-known term, the angle of repose. What is that? If the granular material is there, like corn powder, atta, moida, or like this, just place it. Then, what will be the steepest angle here? Alpha. Without any use of any pot, freely keep it, slump it. Then the maximum angle produced here is the angle of repose. And this is equals to the friction angle phi. In case of solid material, it is denoted by friction angle phi, and in case of this granular material, it is called the angle of repose alpha. Here, to show by this diagram that the P force, applied force P, is equals to the friction force up to the maximum limit, or up to this limiting force, limiting friction, and then when the block starts to move, this friction force suddenly decreases for an amount, and then it is remain constant. Means whatever may be the applied force, still we are increasing the applied force, but no longer this friction force is increasing. It is constant. The references that I have used to prepare this video is given here. So we came to end of this lecture, and in the next lecture onward, I will try to explain some numerical problems on horizontal plane block, vertical plane block, or inclined plane rigid body, how behaves under the action of the frictions, all this. So please follow the lecture. Thank you.